Today, we will discuss sampling. How do researchers select participants in a study? We will go through different sampling methods and generalizability. Let's discuss population and sample first. A population refers to all the members of a particular group. It is the group of interest to the researcher, the group to whom the researcher would like to generalize the results of a study. A sample is any part of a population of individuals on whom information is obtained. Sampling refers to the process of selecting participants from a population in a research study. It is possible that the sample is the entire population, but this is not the case in practice most of the time due to the limitation of research resources. Thus, part of the population will be selected as participants. The first task in sampling is to define the population of interest because you select individuals from that population. Normally, the population of interest is a group of persons with certain characteristics, such as all college students in South Carolina. The target population is the actual population to whom researchers would like to generalize. The accessible population is the group that is available to researchers. For instance, my target population is all college students in South Carolina, while my accessible population is college students at USC. A representative sample is a sample that is similar to the population on all characteristics. Researchers hope to have representative samples. See the graph showing the difference between the representative and non-representative samples. If the population has the characteristic of equal number of men and women, a representative sample would have the same characteristic, while a non-representative sample does not have that characteristic. Random sampling and non-random sampling are two major types of sampling methods. Random sampling is a method of selecting participants from a population by chance, so that the biases do not alter the sample. On the other hand, subjects in non-random sampling do not have an equal chance of being selected. Next, we will introduce three common random sampling methods. Simple random sampling. This is a sample selected from a population where all members have an equal chance of being selected. If the sample is large, the best method is to obtain a sample representative of the selected population. The larger the sample size, the more likely it is to accurately represent the population. Any difference between the sample and the population characteristics are the result of chance rather than the bias of researchers. In practice, it is difficult to perform this kind of sampling as each member of the population must be identified. It does not ensure that subgroups are present in the sampling in the same proportion as they are in the population. Like the example in slide 4, we may not be able to get a sample with an equal number of females and males with a simple random sampling. Stratified random sampling. A stratified random sample means that certain characteristics are represented in the sample in the same proportion as they occur in the population. Strata refers to subgroups on which researchers want to focus. Like the men-women example in slide 4, the strata is gender. Stratified random sampling increases the likelihood of equal representation, especially if the sample is small. It ensures that any key differences of individuals in the population are included in the same proportions in the sample size. In that example, researchers need to identify the subgroups, strata, which are men and women. Then they randomly select individuals from each group with the same proportion as in the population. Here we have 50% each. The disadvantage is that it requires even more effort on the part of researchers to complete the sampling process. Cluster random sampling. It is a sample obtained by using clusters as the sampling unit rather than individuals. This is considered more effective with large numbers of clusters, such as all districts in a state. This is more efficient and easier to implement in schools. For example, researchers only need to contact certain districts with this method. The disadvantage is that the sample may not be representative of the population. This graph nicely shows the major random sampling methods. Please take some time to look at this graph in order to understand the differences between these methods, especially the differences between stratified random sampling and cluster random sampling. Also note that these methods may be combined. The two-stage random sampling method combines cluster and simple random sampling. This combination method selects groups randomly and then selects individuals randomly within those groups. This may be less time-consuming but has good representation of the groups at random. Non-random sampling methods. Researchers obtain the sample by selecting every nth person in the population in systematic sample. If you have 100 persons in the population and you need a sample of 10, you may select every 10th person in the population. The starting point is decided by researchers. A convenience sample is comprised of any group of individuals that is available to be researched. This method is commonly used in educational research. For instance, I only have access to one particular school in a district, so I decide to conduct my study here. As this sampling method is not representative of the population, it is hard to generalize the results from sample to population. However, it is very common to use this sampling method for researchers who need to collect the data by themselves. A purposive sample is selected because the individuals have special qualifications of some sort or because of prior evidence of representation. A researcher's personal judgment is used when making these selections. A major disadvantage is that this judgment could introduce error. For instance, researchers want to study the influence of a particular teaching format on students' achievement scores. They will want to include students in different ability levels based on prior achievement scores to have a more accurate representation of the population. This graph helps you check the differences among non-random sampling methods. Please take some time to review it. So, how can researchers decide the appropriate sample size for their studies? It should be as large as possible with a reasonable expenditure of time and energy. Some basic recommended minimum sample size numbers are provided. External validity, we also call it generalizability. We stated in Chapter 1 that generalizability is a characteristic of quantitative research. We have been using this term a lot in this lecture. External validity refers to the extent that results of a study can be generalized from a sample to a population. As mentioned above, we hope to obtain a sample that is representative of the population of interest to increase the population generalizability. But this is not enough. Researchers may also hope to generalize the results of a study to conditions or settings other than those that have been examined in the study. We call it ecological generalizability. For example, if you conduct the study in private schools, you may not be able to generalize the results to public schools. This is the end of this lecture. We will introduce internal validity and instrumental validity in Chapter 8 and Chapter 9 after we introduce the instrumentations in research studies. Are you ready?